Hello folks, and welcome to polynomial division. We are going to divide polynomials using some synthetic division today. I'm going to teach you how to do that because later on in this week you're going to see why this process is useful and what it's used for. So if you take out your pen and your pencil and your notes and a calculator, just in case we have some calculations you need to do, we'll get started. Let's look at division in general. Do you remember taking 200 divided by 12 and saying how many groups of 12 go into 200? Okay, well you can do that, or you can set it up in this long division that you also learned in 5th or 6th grade. And how did we do that? Okay, so first we said how many times does 12 go into 20? Once. 1 times 12 is 12. 20 divided by 20, subtract 12, is 8. Bring down the 0. How many times does 12 go into 80? 6. 6 times 12 is 72. 80 to subtract 72 is 8. So we said the answer to this problem is 16 with an 8 remainder. Now sometimes your teacher would tell you, when you first started the process, your teacher said, we'll just write 16R8. Okay? Once you started learning what division really meant, you graduated to saying 16 and 8 over how many you divided by, the 12. Okay, well then your teacher taught you about fractions and said we could reduce that 8/12 to 2/3, because 4 goes into 8 2 times and 4 goes into 12 3 times. So you actually wrote this problem as 16 and 2/3, or 16.666666 repeating. Okay, so that is the answer to this problem. Well, how is this going to be helpful? Well, this is going to be helpful because now our goal today is to not divide numbers, but to divide polynomials, where we are going to be dividing x squared plus 3x plus 5 by the divisor x plus 1. But instead of using long division, we are going to use a process called synthetic division. And synthetic division is an abbreviated form of long division that we can do if we are dividing by x plus or minus a number. So we just took a look at what it looks like to be regular long division, where we put the divisor out in front and the dividend underneath the division sign to divide out the polynomial. But today we are going to learn abbreviated form, which is synthetic division. And how is that going to be similar or different than what we're using? Well, there's a lot of similarities, but one major difference. If you remember synthetic substitution, that's what we're going to use. We're going to use that process of synthetic substitution where we use the coefficients out in front. So with the 1, the 3, and the 5. Okay? And so we are using that same polynomial, but what's different is what I put out in front. Notice the divisor here is x plus 1, but what I use here is -1. And that is because what we have to do is we have to take the divisor, which is x plus 1, and set it equal to 0 to find the solution. The solution is what we use up here. So if I were to set x plus 1 equal to 0, I would get x equals -1. -1 is what I would put out in front. And then I would use the process of synthetic substitution just like we did a couple weeks ago. All right, so we are going to go ahead and do this problem. And I have this exact same problem right here, x squared plus 3x plus 5 divided by the x plus 1. So I have the same process here. And let's do the synthetic substitution method. That's going to be very helpful if you remember that process. Bring down the 1. 1 times -1 is -1. 3 minus 1 is 2. 2 times -1 is -2. And 5 minus 2 is 3. Now, with synthetic substitution, we said the answer was 3. That was our remainder. Okay, but that's not our answer this time. When I take a polynomial divided by a polynomial, I should get a polynomial. Okay, so we have to figure out what the polynomial is that I get. So this is our remainder. This is our remainder. The number in front of the remainder, so all of this represents a polynomial. The number in front of the remainder is your constant value, and the one in front of the constant represents the x value. So the quotient of this problem, which is an answer to a division problem, would be 1x plus 2 plus your remainder. Now remember, we don't write R3. We will now write 3 divided by our divisor, which is not the -1, but the x plus 1. And that will be the quotient or the answer to this division problem. Okay, let's try another one. All right, let's set this up just like we did before with synthetic substitution. Every coefficient, so we have x to the 4th coefficient is 1, x to the 3rd, oh, yep, you got to remember, all your coefficients have to be accounted for. X squared is -10, x is the 2, and the no x is the 3. Now, instead of putting the x minus 3 out here, we have to take our divisor and find out what the solution would be. So we set it equal to 0, and that would be 3, so we use the 3 out in front. Drop down the 1, multiply by the 3, add the inside numbers, multiply 3 times 3, which is 9, -10 plus 9 is -1, -3, 2 minus 3 is -1, 3 times -1 is -3, add, and we get a remainder of 0. That's kind of cool. This time we get a remainder of 0. Now if this represents a polynomial, this represents the answer or the quotient. So if that number 0 is the remainder, the number next to it represents the constant. The number next to that one represents the x value. This represents the x squared value, and this will represent the x cubed value. So the answer to these two polynomials being divided would be x cubed plus 3x squared minus 1x minus 1 with the 0 remainder, but I don't need to write that. Okay, let's try it again. Example number 3. Division can be written as fractions. This is just another way to write division. So I'm going to take this polynomial, x cubed minus 2x squared plus 3x minus 4, divided by the polynomial x minus 2. So we are going to put, this is the divisor, okay, but we don't put the divisor out here. We put what it's equal to. What's the solution? The solution is 2, because we're going to add 2 to both sides. So the 2 goes out in front. And then our coefficients and constants from this polynomial goes inside. So x cubed is the 1, x squared is the -2, x is the 3, and the no x is the -4. Bring down the 1. 2 times 1 is 2. -2 plus 2 is 0. 2 times 0 is 0. 0 plus 3 is 3. 3 times 2 is 6. And 6 minus 4 is 2. So now what is the polynomial that you get when you divide these two polynomials out? Well, the 2 is the remainder. The 3 represents the constant term. The 0 represents the x term. And the 1 represents the x squared term. So I have 1x squared plus 0x, which I don't have to write, plus 3, plus your remainder, which is 2, over the x minus 2. And that is the quotient. That is the polynomial that you get after dividing these two polynomials. That's it, and we'll see you tomorrow.